Hello everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try to do it, pause it, and then come back, and we'll be here to try to do it here. Okay, which of the following is equivalent to the given expression? And I have to start up my annotation, which now works. Okay, choose one answer. Aha. Now, isn't this different? No, this is not different to two perfect squares, is it? Oh, but you could factor that thing, right? So
Yes, you can.
I'm doing a bad thing. I'm looking at this before I look at the answers. But it's so tempting just to factor it, isn't it? And then you pull out two.
No. The three of the four choices are products. They have some factored form.
Right.
So
right.
that would lead us to try to factor the given expression.
Right.
And then you look at it with an eye to factoring it and observe, yes, you can factor it.
It's so funny, I'm like a Pavlovian dog, you throw a stick, the dog doesn't think, right? The dog just gets the stick. Right. I see something like this, I just say factor. I don't even just say factor. Just try to factor. And if you factor, it's the greatest common factor factoring. You pull out a w minus 3 squared from both of these, and therefore then you're left with, in parentheses, w minus 3 squared, which is what you get when you divide w minus 3 to the fifth divided by w minus 3 squared, minus 1. And that matches. Look at that. My goodness. So that has to be the answer.
Yeah.
So this very common factoring is GCF factoring. Always look for it. Greatest common factor factoring. Sorry to use lingo. We hate lingo. We speak in words that try to speak in words that everyone understands. So this would be like 8 to the fifth minus 8 squared. You can factor out an 8 squared, and that leaves 8 to the cubed minus 1.
Yeah. I always say, we remind people that w minus 3 with a superscript of 5. That means w minus 3 times itself.
I know. We're going to write it 5 times. So boring.
Yes, I am.
Okay, let me make space for you. Hold on. I got to clear the way.
I'm using another color.
Clear the way for Seth. I know, but still. I like a little thicker.
And then the first three of them are w minus 3 cubed. And the last two of them are some multiplication between everybody. Oops, sorry. So w minus 3 cubed, because there are three of them. 1, 2, 3. And then two of these guys, w minus 3, little 2.
Right, yeah. So this also brings up the idea of what I call the U trick in math. When you have a big expression, you can substitute it with something smaller, like u. So this could be u to the fifth minus u squared, where u is defined as w minus 3. So let's work in u. It's pull out a u squared, w cubed, u cubed, u cubed, u cubed, u cubed, u cubed.
Yeah.
Minus 1. And then you substitute back for u, the w minus 3. It makes life easy, see? Substitution. Substitute one variable for a bunch of other variables, and then you manipulate the simpler variable.
This is one way to look at it. But my way is the other way. To just instead of you gave a new name to w minus 3.
Right. Yeah.
I simply use w minus 3 as a quantity.
Yeah.
As a quantity,
of
and
course.
I didn't give it a different name.
Of course, I'm just showing different ways to look at it. Of course. Yeah, you would do it. It's faster to do it this way. You just see the w minus 3 as a package, and you just factor out the package. I use the word undistribute. Isn't that a horrible thing to say? To undistribute? Because You see, if you distribute this, isn't that horrible? That doesn't exist.
That means factoring.
I know that's what it just did. But you see, it's sort of undistributing, because if you distribute this here and you distribute this here, you get this. So it's sort of like thinking about it like undistributing. But undistributing is not a word. Just spit it up. No, it's embarrassing. So, should we look at their answer?
Yeah.
Okay, let's see. And today's Throwback Thursday, so we're going to try to look at the answer pretty quickly so we can get to a Throwback Thursday question. Oh, by the way, this is what we think the answer is. Okay, good. And let's see how they did it. 4 steps, not that bad. We could put it on one screen.
Yeah, they did it Joel's way.
What, they made an A? Oh, yeah, they didn't have to do that. It's fine. Yeah. Usually use you. Is that true, Seth? Seth has a PhD in math. Congratulations, Seth. Don't you usually use you? Is that no? I thought you use you most of the time. There's no standard for when you make a substitution to use you?
No.
Okay, I always thought it was. Okay, anyway, so they do this, right? They make a substitution, they factor this. Notice it's undistributing. If you distribute this to this and this to this, you get this. That's a good way to check. Note, look, they even say if you use the distributive property, you get it right. So they say to check, always a good thing to do.
Yeah.
You substitute back, you get the answer. Okay, so should we go to Throwback Thursday?
Yes.
Okay, Throwback Thursday. What we do, we go back about 20 years. Here's a book. My God, it's old. From the early 2000s, late 1900s, late 1990s, where they have tests that had some of the questions had a different feel. And you'll see what we mean. The tests now, post-2016, more reflect what you learned in school. I doubt you had a problem like this. Uh-oh. Are you kidding? Wait, hold on, I'm embarrassing myself. There it is. Okay, the computer knew what to do. I doubt you had a problem like this in school. So everyone, good luck. 2 lists of 5 consecutive positive integers contain exactly what integer in common? The sum of the 5 integers in one list is how much greater than the sum on the other? I'm not in the mood to do it.
So how do I think of it? Here's the first list. Okay. They're consecutive integers. So let's call them, so this is what I do. I think of the first list. These 5 consecutive integers.
Right.
And in order for them to have one in common, the other one has to either be like this or be the other way. Right?
Very smart. Yeah.
Yeah. So what we mathematicians say, without loss of generality, let's consider this case. And then the sum of the 5 integers in one list is how much greater.
You have to make that second list 5, by the way. You only have 4.
Okay. So this looks like an algebra problem. So what I'm going to do is let the first integer be a.
Okay.
And therefore the integers up here are a plus 1 up to a plus 4.
Okay.
And then this integer is also a plus 4.
Right.
And the next one is a plus 5 plus 6, 7, 8. So the last one is a plus 8. Okay, and then they say the sum of the 5 integers in one list is how much greater. So let's pick the greater list. The sum of the integers in the greater list is, a plus 4 plus a plus 5 plus a plus 6 plus a plus 7 So how many did I get? All
Only
five?
4. You only got 4.
Yeah, plus 8 plus 8. So the sum of the integers in the bigger list, the sum is 5a plus, the
Right.
sum of,
So you got 9, 13, and 8.
yeah.
You've got what? 17 and 13.
Okay, so that's also 5. We take the average, 12.
Oh, I see.
Now what's this? Take the average is 6 and multiply it by the number of things. 6 times 5, 30.
Yeah, 30, yeah.
Yeah. So the sum of the first one is 30.
30.
And the sum of the other one, well, is like the sum of the first one, except there are 5 fewer 4s.
Well, it's 1, 2, 3, 4.
Yeah, so there's a 4 here and a missing 4 here.
You just add these up. Why make it so hard? Just add those up.
So it's 5 4s, therefore 20 is the extra number.
Or you add these small ones up. It's 5a plus 10.
Yeah, so I took a shortcut instead of figuring out 10.
Right. Okay, now are you sure
0
that's
plus
going to be true?
1 to 4 is 0 plus 4 divided by, it's 2 times 5 is 10. Yeah. So so we got a couple ways.
Okay, wait. But you said it could happen another way. It could happen this way.
Well, the thing is,
so what's the justification for not having to test this?
Well, the thing is, the sum of the integers in one list is how much greater than the sum in the other. Well, only one list, only one of the two lists has a greater sum than the other list. It's in fact the list of the smaller numbers is a certain positive amount less than the other one.
Got it.
Right.
Well, also I see here that if you consider this situation, oh come on, Zyport, this is why we don't use Zyport anymore. If you consider this situation, it really is the same as this situation. Because this situation, you have a list of 5 smaller integers, and then they share the last number.
Yeah.
Oh, right. So this is, if they're considered sharing the lowest, in other words, if they're considering sharing the lowest of this group, it's really the same as sharing the highest of this group. Right. So it's really the same problem, just sort of reversed, so you don't have to test the other case.
So actually, if they're asking arbitrarily which sum is greater, by how much is each sum greater, if you take it in the opposite order, the amount by which it's greater is negative 20. Ooh. So they really should have.
Well, we have the answer sheet.
But I think that my guess is that they intended to that the amount of greaterness is a positive amount.
Right, because you can always start in this. You can always, Seth hates when I make thick things, but you can always start in this direction, right? So you have a list. You have a list A. You have a list B. List B is always going to be 20 greater than list A, and then you just keep plowing through the number line.
Oh no, yeah. List A and list B.
No, list B is always 20 greater than list A.
No, we give it another one. So here's list A, and here's list B. We know nothing about the which one has bigger numbers? How
Oh,
much how much one list? How much is the sum of the numbers in one list greater than the other list?
oh,
Well, it
wow.
depends on the order,
Right.
which is
Oh,
saying
I see.
greater.
And then they'll tell you in the question that you need to go, that you're going left or right. It's just implied that you're going left or right. You can also go right to left, at which point it cannot be determined
No,
from the
I'm
information given.
not. Let me uh, clarify my picture. What I meant here was that I do not specify anything about which of the lists is bigger
Right.
numbers.
Yeah, yeah, yeah. It doesn't say. So you're
Yeah.
saying that it's
So
likely
I
to
think
be positive 20.
I think the problem is not that is a bit ambiguous.
And this is from
Uh,
the actual
And
SAT people. This isn't from the con.
okay,
This is
so
actual legitimate SAT.
let's see what they
Yeah, this is a toss-up, right? So
yeah.
technically, if it's 20, it's not technically. There's an issue with this question. I wonder if anyone complained back, 20 years ago. Well, we all agree
Probably.
that you don't learn this type of stuff in school. Uh, okay, so this is section 3, question 33. Section 3, question 33 is D. A, B, C, D. Yeah, D is 20. Yeah.
Yeah.
Yep. Yeah, so it's not a really fair. One can argue that it cannot be determined. But you're right, the intention was D. Yeah. Ooh, a bad question. Seth would say, well, Seth is a PhD in math from MIT. He's a professor emeritus from University of Albany. At University of Albany, I'm PhD in math. Seth's brother here. My claim to fame is being Seth's brother. And we're here to hopefully show you how to approach SAT math questions. On Thursday, we go back to show you how the questions were a little different back then. So yeah, this doesn't happen too often, does it?
Well, I now have having thought about it and seen it. Now I could give you a more direct explanation.
Wait, do you agree that the answer is 20 with no ambiguity, or is there still ambiguity?
No, I still.
There's still ambiguity.
Yeah. However, what I'm going to say is a more direct way of seeing the results.
Oh, sure. Let's see it.
Following from our looking at it, fresh and not having, coming out stumbling a bit. Now we have the following idea.
Yeah.
The principle is that in this situation, each number in the list of bigger numbers is 4 more than the corresponding number in the list of smaller numbers.
Right? Oh yeah. You mean you can see that if you do a brute force. So let's do 3.
Yeah. So you can see it somehow. That's what it's in order for it to work.
9, 10.
Yeah.
11. So each one is 4 more, right? Look at that.
And there are 5 entries, and therefore, how much more is in the sum of the bigger list is how much more in each element in each entry times the number of entries. Number of entries is 5. The amount by which each one is bigger than the corresponding one and the other is 4. 5 times 4 is 20.
Wow, that was really smart. Yeah.
But the smartness comes from grappling with the problem and playing with it, figuring out the solution in a clumsy way.
Yeah.
And then reconsidering it, running it through your mind to get a better idea of what's really happening.
Right. Yeah. Now that's how you do math, right?
Yeah.
Yeah. So I never had a chance to really struggle with it because Seth swooped in before I had a chance to think it through my clumsy way. Seth has the benefit of having a PhD in math, right? I only have a PhD I have a degree in mechanical engineering. So, I don't know how long this would have taken. I don't know how long.
The math that you used in mechanical engineering, there's nothing like this.
That's right. I don't have the experience with this question, so I would eventually have gotten it. Maybe I see. The thing is, you know what mistake I would have made. I can tell you immediately what mistake I would have made. I wouldn't have noticed immediately that it's exactly one integer in common. And that would have stumped. I could see right now that I wouldn't have noticed that initially. And I would have been stumbling, saying, well, I don't know, you have 3, 4, 5, 6, 7, and you have 4, 5, 6, 7. I don't know what's going on, right? I probably wouldn't have noticed this. Key point. You gotta read the question carefully and use everything in there, right? Otherwise, you stumble and you don't get it. Yeah. So of course,
well, it's also critical. It's also critical that the two lists are of consecutive.
Well, that's like right in front of us, I mean that's like the one.
Well, I don't know. I'm the thing is this Brown statement is it occupies about 2/3 of the second line.
Yeah, I know.
So it's hard to miss.
That's why it's embarrassing to admit that I suspect I wouldn't have noticed that on the very first run of it.
How do you know?
That's the thing, that you swoop in and do the problem so fast and you don't give me a chance, which is good, because who's going to want to watch a video and watch me struggle, right? We want to get the answer quickly, right? So that's a massive advantage on these questions than I am. Okay, so that's it for Throwback Thursday, right? Hope people enjoyed this video. Please like us, dislike us, give us comments, and we're here to hopefully give different approaches on the SAT math questions in terms of studying. Go to Khan Academy. They have hundreds. They have 600-700 questions per test, the digital or the non-digital. Practice on there. They partner with the SAT, and of course take as many practice tests as you can that are given by the SAT. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And we hope to see you next time we meet, which hopefully will be tomorrow, because we try to meet daily. Okay, that's it, right?
Bye.
Okay, everyone, take care. Bye.